All right, so what is the context mesh? This is something I've been working on for many weeks now. I kind of want to explain what it is and how it can help businesses. But in order to explain what it is, we kind of got to talk about vector storage and databases in general. Okay, so one of the biggest draws to the AI world for businesses, whenever AI became commercially available a couple of years ago, is vector databases. Basically, what a vector database does is it takes information. Say you have a bunch of documents, right? You can't fit all that inside of the context window of a prompt, but you want an LLM to assist you in your business operations. So you take all of your documents and all of the business knowledge that you have and you put it inside of this database. And that information is turned into vector embeddings. Basically, they're turned into numbers. And these numbers, how they relate to each other is no longer by keyword, right? So before, if you did a search inside of a bunch of text, the only way you could really find what you're looking for is to match the keywords in the text with your query. That's how old school Google and other search engines worked, right? This is called lexical matching. But what vector embeddings do is it allows that to no longer be the method for search, and instead it's semantic, it's by meaning. And the reason that happens is because of the closeness of the numbers, right? So the number for cat, the number for dog, and the number for pet will all be pretty close to each other. So those are semantically similar. And for that reason, when you run a search in a vector database, say for pet, cat and dog will show up higher in the results than sandwich. Semantic search by meaning, is a really attractive concept, and the fact that that could be deployed for a business is pretty cool. But it has its downsides. It has its limitations. For example, it doesn't work at all for specific information. And what I mean by that is, let's say you have an order number 0, 1, 2, 3, 4. To an LLM, order number 0, 1, 2, 3, 4 and order number 0, 1, 2, 3, 5 are semantically identical. That's a problem, obviously. So it definitely does not work for specific information. And businesses have more than just documents, right? They have spreadsheets, they have tables with very specific information in them. So a way to combat that was hybrid search, right? So basically you could make the result even more relevant, even more correct by adding keyword search to it. So then you could search both keyword and meaning. But that still doesn't solve the specific information problem. That just makes sure that your results are as accurate as they could be in a fuzzy search, right? So your policies, your guidelines, that kind of thing, it's going to probably find the right answer there. But if you're asking for a very specific, I need to know, the clock in time on this day for John Smith, that's going to be a lot harder because of the semantic similarity thing. So what businesses actually need are both hybrid vector systems and a way to recall and retrieve specific information, which the tried and true most effective way to do that is SQL. The problem is your team has to have people who know SQL because it's basically another language. It's a lot of people consider it a programming language, but either way, it's something that you have to learn, or people on your team have to learn in order to utilize. So the answer to that was LLMs trained for text to SQL, but these also have struggles. And the reason is because they create an SQL query without knowing fully all the information about your spreadsheets. And these are going to be dynamic too, especially if you're talking about logistics or anything that changes, financials, anything that changes regularly. These are dynamic concepts, and having an LLM spit out an SQL query in a changing landscape like that can be a recipe for failure for sure. So the answer to that is agentic SQL query building. And this is where you have the LLM actually peek at the information first, right? So it determines what the nature of the query is about, and your query being in plain language, and then peeks at the tables, finds which tables are the most likely to be relevant to this query, peeks at their schema, that means all of the column names, and then a couple of rows of sample data, and then it would know how to build the query. So combine these two inside of a database that has both unstructured and structured. This is really and truly something that businesses could benefit from, because it allows an LLM access to their data without much room for hallucination, right? Because The unstructured data is there and it's pulling it through hybrid querying. And then the structured data is there and it knows how to look at the information before developing an SQL query. And anyway, this is key. So I have taken these concepts that existed, although mostly separately, put them together and added some more optimizations to the top of it. In the context mesh, basically, we take a hybrid vector store, right? So this is a vector store that keeps vector embeddings as well as indexed full text, right? So all of the content is there and it can be searched via vector as well as keyword. And then in the same database structure, although in different tables, you have your structured data with an agentic SQL query generator, but mine has a spin on it. Mine actually has a tiny mini vector, hybrid vector store with a cheat sheet of all of the SQL queries that would be needed. And at the point of query, what the LLM will do is run a search for what it thinks is the most likely query or query type or query structure and pull the actual queries from a query dictionary. And that will give it the last bit of information it needs to ensure that the query that it's about to give to the user to use in a search is correct. So we've optimized the query generation, so agentic text-to-SQL works beautifully. But on top of that, another realization I had was that graph data would be really useful. So here's the thinking behind that. When you communicate with another human, a lot of times you get more context than you asked for, right? So if I say, hey, what did Bob Smith order? Somebody can answer me with Bob Smith ordered a camera, and that's it. But a lot of times, humans, we like to add context, right? Bob Smith ordered a camera. It actually was ordered 2 weeks ago, and he hasn't gotten it yet, and this is a VIP customer. That is not relevant to the query, but it's very useful information. So how do we get the machines to act like that too? And that's when I realized that adding graph to the whole query situation would be the best. Now this does already exist. It's called GraphRag. And GraphRag is a really cool system. People approach it in different ways though. Like sometimes I see the nodes and the edges of the graph be turned into vector embeddings, which I'm skeptical works in most practical use cases. But even when it's not, GraphRag is really good, but it needs some optimization, which is what I've done in the context mesh. So we added essentially a GraphRag. We added a graph to the whole system. We utilize language models to pull entities and actions with very stringent rules on exactly what it's pulling to ensure that the information is relevant, tight, but also useful. And then it's not really re-ranking, but more we attempt to filter non-useful noise information. So basically what happens is a query will result in what's called graph triples. And a graph triple is an entity, its relationship to another entity, and then that other entity. That's a triple, right? So you have thing, how it's related to the other thing, and then other thing. And we make sure that all of that is filled in really well, right? Tons of metadata. We even optimized in another way by using a temporal model and including events as nodes, right? So not only do you have thing and then its relationship to another thing, but you also have events themselves as things. And these include timestamps. And so that way it's easier when you query the graph to pull a timeline of events, right? So now when we look up a specific order from Bob Smith, not only do we see the camera that he recently ordered, but we see a timeline of every other thing that he has ordered, all the returns, customer support interactions, et cetera, et cetera. That is not relevant to the query, but I call it relevant adjacent because it's really useful, especially in a business use case. So we use the temporal model. We do filtering to ensure that the triples are useful and at very least relevant to the subject being discussed. And then we add that to the retrieval. So the retrieval is what I call composite retrieval. The composite retrieval is your vector and full text search. Maybe SQL. Not every situation requires SQL because not every bit of information is inside of a structured table. So how the agentic system works is it looks at the query and it thinks, would SQL be helpful here? And then it extracts the important keywords from the query and then looks to see if there are any tables that match those keywords. So got to make sure that the tables are logically named. the file names are logically named. So it looks at the file names of the tables. If it finds any that match, then it'll do the peeking and figure out, how to generate the SQL query. If not, then it'll just leave it null. Like SQL doesn't have any information to add to this. And then the LLM will use a similar process to develop a Cypher query, Cypher being the query language that is used in graph queries, right? So it'll put together the Cypher query using a cheat sheet, a small hybrid vector store that keeps the cheat sheet. And it'll look at that to make sure that it's structuring the query correctly, execute the query, pull back the helpful triples, and then a re-ranker is used on the vector data. So a smaller language model looks at everything that was brought back and then says, nope, those are not relevant, these are relevant. So you have relevant vector, you have specific rows if there's an SQL table that can assist in this query, and then you have helpful triples. And those are all put together, fused in the final composite query that's brought back, and then that can be delivered to a language model. Really, really useful system for businesses because it gives the AI all the information necessary to properly deal with customers, with contractors, really most use cases in business, because it turns all of your business data and makes it useful, makes the AI connected to it as intelligent as possible. So that's what I've been working on. I created a light version, which doesn't have the temporal modeling. It's a little bit easier to implement though, because it's just some copy and pastable scripts that you put inside of Supabase. But the full version is what I'm working on right now. This will be a full end-to-end software. Anyway, I just thought I'd share a little bit of knowledge and information about databases for business use cases and what I'm working on. Be well and do good things. Cheers.